Good morning, Bridge students. Today we're going to be applying deductive reasoning for the first time here this term in a situation where we have parallel lines and what's called a transversal. So the objective is right here. It says students can recognize angle relationship patterns with parallel lines and transversals and use deductive reasoning to solve problems based on these patterns. Here we have two parallel lines. They have names. The names are M and N, and these little arrow type symbols just indicate that they're parallel. The transversal is the line here that cuts across them. I've named it T. That's a cursive T, not a plus sign. Okay, so here is the reasoning pattern with this situation. Two parallel lines, a transversal, and the reasoning pattern is this. It's always true that if we have two parallel lines cut by a transversal, then several things are true, and I'm going to write them down first. First of all, what are called alternate interior angles, AIA, are congruent. I'm going to talk about those in a second. Also, alternate exterior angles are congruent. And what are called corresponding angles. That's not California, that's corresponding angles are congruent. And then finally, what we call same side interior angles. They're not congruent. They add to 180 degrees. Okay, so often students get really hung up on this, but it's just a matter of memorizing patterns and also understanding maybe what interior means. So for instance, I'm going to show you the space right here that's interior to the parallel lines. It's inside the parallel lines. Okay, now there's two pairs of what are called alternate interior angles. These are the easiest ones, I think. And they're interior, and they're on alternate sides of the transversal. So for instance, here's one of the pairs. Here and here. Those are alternate interior angles. I'm going to use another color. Here would be alternate exterior angles. They're exterior to the space between the two parallel lines, and they're on alternate, in other words, opposite sides of the transversal. So for instance, maybe here and here would be alternate exterior angles. Okay, there's another pair, by the way, here and here, yeah. You can mark it with like two little blue marks like this. And I'll let you think for a sec, see if you can hunt down the other pair of alternate interior angles. Where might those be? Okay, so I'm going to go back here. See you later, guys. And say that corresponding angles, there's four pairs of corresponding angles. They would look like this. I'll put them in, I don't know, lime green here. This angle corresponds to that angle. And then there's finally what are called same side interior angles. I'll make those magenta. Say, for instance, this one and that one are same side interior angles. They're on the same side of the transversal and inside the two parallel lines. There's material on this in your book. I'm going to give you a Khan Academy video on this. Once you get used to it, they're quick patterns to memorize. So these are the different kind of angles we have, and we know that they're congruent. We're not going to, in this class, prove that they're congruent. We do that in Math 1, but just we're going to assume that they're congruent, meaning that they have equal measure here. Okay, so Next piece. There's a second reasoning pattern that you need in order to succeed at this. And this is a problem where we're given that, say here, lines M and N are parallel. They're cut by a transversal T, and then we have angles, I'm calling them A and B. You can call them any letter you want. The A and B are just placeholders. But we know that angle A is 3x degrees and angle B is 2x plus 10 degrees. And here's our secondary logical reasoning pattern. Since we know that line M is parallel to N, we know that these are alternate interior angles. They're on, again, the interior, here we go again, of those two parallel lines. And they're on alternate sides of the transversal T, right there. Okay, so if that's true, by the pattern that we talked about here, the reasoning pattern we talked about here, we get to make a truth claim. And the truth claim is just that 3x is going to be the same as 2x plus 10. And then from there, that's what allows us to use more deductive reasoning to solve for x. So we'd say 3x equals 2x plus 10. And we're going to use logical operations. In this case, it's the subtraction property of equality, or making zeros. We're going to make our 0 here. I love this magenta color, so I can make my 0 magenta. Ooh. And back to black here. We end up with 3x minus 2x leaves 1x left over. The 2x's go away because we made a 0, and x is 10, which, by the way, shows that angle A is 30 degrees and angle B is 30 degrees. That's it. Have fun with this deductive reasoning pattern, and I'm going to have some assignments for you to work on this later today and tomorrow.